All right, guys. So today is day 3 of naming and names and formulas of chemical compounds. And day 3 today, we are focusing on writing formulas for ionic compounds, kind of our introduction today. We're going to do more of it next class because next class we're going to kind of add on a little extra thing. There's these things called polyatomic ions. And so on Friday, we're going to talk about what those are and how that plays into how we do names and formulas for ionic compounds. But for today, we're still working on the ones that we call binary. Binary meaning they're just 2 elements, so it's just a metal and a non-metal, okay, for the ionic compounds. So Monday, we wrote their names. Today, we're going to do the opposite. We're going to be either given the name or we're going to be told, you know, hey, write the formula with that this metal and non-metal would make if they give us the symbols for them. So I'm going to go ahead and share my screen, and we're going to kind of go through what's on Canvas. And then we're going to look at a video. We're going to do some practice problems together that are similar to what you guys are doing on your Google Slides assignment today, and kind of check to see how we're doing with all this. So your lesson today, it's writing formulas for ionic compounds. So you have your little interactive lesson here. So I'm calling it chemical nomenclature 3 because remember I told you guys that nomenclature is like the fancy word for naming systems, or how do you write names and formulas of things. So chemical nomenclature, and this is number 3 because this is our 3rd day. So today we're focusing on writing formulas for the ionic compounds. Now, sometimes if you're just told like what's the formula with barium and chlorine, then you would look up the elements on the periodic table, find their charges, and then follow this process. Sometimes though, you're not going to just be told the names of the elements or the symbols of the elements. You're going to be given a chemical name, and you're going to have to go through this process. So that's when we get to the video practice, we're going to take a look at somewhere they're actually going to give us the ionic compound name, and we have to translate it. So you guys didn't know that chemistry is also kind of a foreign language class, because we have to translate chemical names to formulas and chemical formulas to names. And there are all these rules that say like how we do it. So, you know, we had covalent last week, now we have ionic, and there's different ways that they do their names and formulas. And then after Thanksgiving break, we have one more type that we're going to talk about. They're called acids. And acid name and formulas, they have a slightly different pattern that they follow as well. So there's a lot of, you know, you have to practice this a lot in order to get better at it, because you have to make sure that you're doing the correct method for doing the name or the formula depending on the type of compound. And the only way to get better at it is practicing. So that's why after we kind of go through this today, we're going to take a look at some and kind of practice them together before you have to do it on your own. Because just like if you're in a sport, or if you are playing an instrument, or you're in choir or whatever, your cheerleader, drill team, whatever, if you're in any of those types of things, the only way you get better at them is to practice a little bit every day, or, you know, maybe every other day, whenever you have your practice. My point is you put a lot of time into it. And so if you want to be able to write your names and formulas correctly, that's the only way to get better at it, is to practice more, okay? So for writing the basic formulas for ionic compounds, what we start off with is I always need to know what are the symbols for my elements first off, okay? So if they give me the name, then I need to know, okay, from the name, what element symbols do I need to use? If they don't give me the name, if they go ahead and give me the symbols, then I need to know the charges for the elements. The first thing you need to know is that when we do these, the positive ion is always first. That's the metal. Okay, so when, just like in the name, the metal always goes first, the same thing in the formula. So this one, they've given me barium and chlorine. So I looked up Ba and Cl. If you look up on the periodic table, how do I know that barium has that +2? I look at what group it's in. Okay, we talked about this a little bit on Monday, that the groups correspond to the charge. So barium is right here. It is in group 2, the second group, which is the alkaline earth metals. And all the metals in this group 2, they always have 2 valence electrons that they need to lose when they become an ion. And so because all of them have 2 valence electrons and they all lose those 2 valence electrons to become an ion and become stable, everything in this group has a +2 charge, okay? Everything in group 1 is going to be a +1 charge, okay? And then as we go, we're going to look at some of the other groups, because you need to know the charges for these groups, okay? So when we get to a little later, I'm going to kind of recommend that you write some of this in your notes or draw it out, okay? So then I look up my nonmetal, which in this case, the Cl chlorine, if I look here, it's not labeled on this because this is really more talking about barium here. But chlorine, if you look on your periodic table, it's one of the ones that's over here in the next to last group. It's in group 17. And everything in that group, they need to gain 1 electron to complete their octet and become stable of their outer shell of valence electrons. So since they all need to gain 1 electron, everything in this next to last column, which are the halogens, they all have a -1 charge. So that's how I know these numbers for the charges. It's based on the group that the element is in on the periodic table. The only ones that doesn't work for are some of those transition metals, and we're going to talk about them later. Their charges I get from the Roman numerals in the names, like we talked about on Monday. But all of my regular metals and nonmetals, not transition metals, I look at what group they're in, and that group, I should know the charge for everything in that group, okay? What we've done here is we've looked up all of these. So aluminum, again, here's another example. It is close to the non-metal metal line, but it is on the left. It's considered a metal. So it's going to be a +3 because it's in group 13. So it needs to lose 3 electrons because it has 3 valence electrons. So once I figure out the symbols and the charges, I write them out like this with the +1 always written first. And then there's 2 methods that you can do this process. Okay, so here in your Canvas lesson, we're using what's called the crisscross method. And what I do is I take the numbers from my charges, not the sign. So I don't move the plus and minus. I only take the numbers and I crisscross them down, and those become the subscripts for the element, okay? This is just one method. When we look at the video examples in just a second, you're going to see that there's a more than one way to do this, okay? So whichever way makes the most sense to you, then use that one. I personally don't like this crisscross method. It simplifies things for some people, but what happens is people leave these ones, okay? And as we're going to see in just a minute, we don't leave the ones in the formula. So doing the crisscross method, it's easy and, oh, I'm just crossing the numbers down. But then at the end, you have to remember to adjust the numbers a little bit, okay? And sometimes we forget that. So that's what they've done here, okay? They've just crisscrossed all of them. So the 2 here for magnesium came down behind and became the subscript for the carbon. The 4 on the carbon came down and became the subscript for the magnesium, okay? Notice again, we did not move the charges. There's no plus or minuses when we write the formula down here. We just have the numbers. So if you do this crisscross method, the last step is you have to do what we call simplify or reduce my subscripts. And the reason I do that is because I want to have the smallest whole number ratio for my subscripts. So right here for barium BaCl2, which is barium chloride, it says you can kind of think of the ratios like fractions. For every 1 barium ion, there are 2 chlorine ions, okay? Anytime you have a ratio with a 1, anytime one of your subscripts is a 1, you can't simplify it because 1, that's the smallest whole number you can get. So you just need to remember if you have 1s that you need to erase them or delete them. So the final formula for this should be BaCl2 because I have 1 atom of barium and I have 2 atoms of chlorine to balance each other in this compound. Now for this one, for the magnesium and the carbon, if you look what happened. Up here I have 4 and 2, but now it's a 2 and there's no number here. So if there's no number, that's a 1. So this is where you do have to reduce. You have to simplify, okay? By writing it with the 4 and 2, we're saying it's like this. But I can reduce that because 4 and 2, they have a common factor. I can reduce them and divide both of them by 2. So if you have even numbers like this, you want to do that. You want to divide them until you get to where you can't anymore. And so if I divide both 4 and 2 by 2, because that's their common factor, then the 4, it becomes a 2, it reduces down, and the 2 becomes a 1, and since it's a 1, we don't write it anymore. The reason we do this is because in reality, our ionic compounds, they're not like the covalent ones. They're not molecules. They form these really big crystals, and so they have like repeating grids of the positive and negative ions. And so there might be like 50 of each atom, like I don't know, but they're always going to be in this ratio. They're always going to be a 2-to-1 ratio. So if I look at this picture, there's twice as many Mgs as there are Cs in this picture because that's the ratio that they follow, okay? And the whole point of ionic compounds is this ratio is what's balancing my charges. Because it says right here, if I add up all the positive charges and I add up all the negative charges, and then I put them together, they're going to cancel out. They're going to balance, and the whole thing is going to be 0. Okay. And so that's what I have to keep in mind when I'm doing my formulas. For this last one, AL2O3, that one actually cannot be simplified because 2 and 3 is an odd number, and that's a prime number, which means it can only be divided by itself and 1, and it doesn't have any factors in common with 2. And so because of that, that one doesn't need to be reduced any further. So, you know, you have to pay attention to, do you need to reduce it or not? And that is sometimes what throws people off. And so when we look at the example ones in the video, I'm going to show you later, the method they use to write the formula is a little different. You're still going to get the same end result, but I actually like the other way better because it gets rid of this step where you don't need to reduce anything. Okay. You do have some practice questions on here. So after you kind of have gone over this, if you haven't already gotten to this yet, you can practice, do some questions and check to make sure you're understanding it correctly. But I'm going to go ahead and go on because we're going to look at this all together. So this one, it's showing you kind of like a condensed version of the periodic table. And on the video we're going to look at in a minute, he has one similar to this, okay? Except he actually leaves the transition metals off of his. But what I want you guys to pay attention to is that number 1, okay, even though the stair-step line is not drawn in here, it's kind of over here a little bit. Notice everything on the left, those are all of our metals, okay? Are the metals typically cations or anions? So looking at this, are the metals positive cations or are they negative anions? What do you guys think? So everything is kind of all over here on the left. These are our metals. Oh, somebody's saying something in the chat. Let me check. Yes, they are cations. Thank you, Sarema. So if you look, all of everything over here on this left side, all these are positively charged. Everything over here on the right, these are negatively charged. These are the nonmetals. So because remember, right in here is where that stair-step line kind of goes zigzagging down diagonally. So everything on the left is a metal, and metals are always positively charged cations. Everything on the right are the nonmetals, and those are the negatively charged ones that are the anions. Okay. Now, the next one asks about, says group 1 metal ions have a charge of what? So looking at this picture, first off, I need to know, where is group 1? What is a group, and where is group 1 located on here? Yes, positive, exactly. All right, so what is a group on the periodic table? Is it a vertical up and down column, or is it the horizontal rows going left to right? What do you guys think? Y'all are awfully quiet today. Nobody wants to say anything other than Sarema. All right, so groups are yes, the groups are the families. They're in the vertical columns going up and down. So if I'm looking for group 1, where is group 1 located on here? Left, right, middle, where's it at? If I was describing where it's at. Let's see. Oh, yes, thank you. I was about to ask somebody, but yes, thank you, Sarema. It's all the way over on the left. This is group 1, okay? Group 1 is hydrogen and the alkali metals. So if I look at that column, what is everything in that column? What charge does it have? Mm-hmm. Gabriel, what do you think? What charge does everything in this first group have? So is anybody there today? Camila, what about you? In this first group, what charge does everything have?
Positive.
I say, Camila, if you're trying to talk, you're muted. Your box lit up, but I can't hear anything because you're on mute.
Positive charge.
Okay, I don't know if you're trying to answer. I still can't hear anything. Okay, so group 1 here, they are all plus 1. So that's important to know, because if I look at whatever element, any element in that column, it's always going to be plus 1. Okay. Same thing, the next one asks about group 2. They're right next to group 1. If we look, they're all +2. So anything in group 2, they're always going to have a +2 charge. If I keep going, it says, what's the relationship between the charges of the metal ions and their valence electrons? So how many valence electrons does group 1 have, and how many does group 2 have? And how do you think that relates to these charges? It's kind of what this is asking. So let's start with, how many valence electrons does every element in group 1 have? Let's see. Layla, you remember? Group 1, how many valence electrons does everything have? I'm not muted, right? Like, no, y'all can hear me. All right, so apparently Sarima is the only one participating today. So yes, group 1 has 1, group 2 has 2, and so their charges correspond to that, because the charge is related to how many electrons, valence electrons, they lose, okay, to become stable. So since the group 1 has 1, they lose that 1 electron, so they're a +1. Group 2, they have 2 valence electrons, they lose both of them, so they're all a +2. If I come over to group 13, where aluminum is right here, remember group 13 has 3, and so aluminum, if you notice, it's a +3 because it loses all 3, okay? All right, let's see, last question. Non-metals, are they cations or anions? So looking at this, we already kind of said this earlier, so I'm not gonna make us answer it, because we already kind of talked about that they're over here, they're the negative anions. What I want you to notice is, just like the metals went +1, +2, and then +3 for this aluminum group, they kind of go backwards. So the first one here, this is group 15 with nitrogen and phosphorus at the top. They're -3, because remember, they have 5 valence electrons. They need to gain 3 more to get to that complete octet of 8. Oxygen and sulfur in group 16, they have 6 valence electrons, so they need to gain 2. So that's why they're -2. And then here in my last group, this is my halogens, fluorine, chlorine, bromine, and iodine. And they have 7 valence electrons because they're in group 17. They need to gain 1 more to get to their octet of 8. And that makes them all -1. So those 6 groups, okay, you need to know that those groups have those charges, okay? Like, period, end of story, okay? If I ask you what charge does an element have, you should just be able to look at a periodic table and you should be able to tell me its charge, okay, if it's in one of these groups that we just talked about. Now, the transition metals, they're a little different, okay? They're a little weird. The only transition metals that don't have multiple charges are right here: silver, zinc, and then there's actually one more that they kind of left off this picture. It's cadmium, it's Cd. It's right below zinc, and it's a +2 charge as well. But other than silver, cadmium, and zinc, all of the other transition metals and tin and lead over here in group 14, they all have multiple charges, okay? So this is just showing us the most common of them. So like iron can be 2 or 3, nickel can be 2 or 3, copper can be 1 or 2. Tin and lead, they can be 2 or 4, okay? A lot of the other ones, some of them have, like, 5, 6, 7 different charges, but these are the most common ones that we're gonna see a lot of the time that are in compounds that we'll use, okay? So down below this, here's another, like, this is a full periodic table, and you are practicing identifying the charges and for the elements. So you're gonna just drag it to, whichever one you think is the correct box for its charge when it's an ion, okay? And then you can check yourself. All right, so putting this together, you have a final, like a practice, so you can practice, and what it's going to do is it's going to highlight, and you can click here to zoom if you need to make the periodic table bigger, but it's going to tell you, okay, what is the formula for the compound made by the 2 elements highlighted? So this one has Li, which is lithium, and it has bromine. So I'm trying to make lithium bromide. That would be the name of that, because it's an ionic compound. And so I need to know, based on the groups they're in, what charges do they have? And then I follow that process about crisscrossing so that I'm balancing the charges, and then checking to make sure, do I need to reduce it at the end? And so you have your choices here that you can practice with. And you have several, I think there's 5 or 6 practice questions on here. Okay, that's for you to do on your own to make sure that you're understanding. So what I'm going to do now, we are going to flip over here, and I'm going to flip to, can you guys see this YouTube video now? Yes, no, maybe. Okay, thank you. All right, so what we're going to do now is I'm going to kind of go through here and I'm going to let him show you. This is the other way that you can write formulas that does not use the crisscross method. So I'm going to play the first couple minutes or so, and then I'm going to pause it every now and then, and we're going to go through and work through some of the examples together, okay?
Formulas for ionic compounds. So what this means is we're going to start with a chemical name like magnesium chloride and learn the steps that we have to go through to take this chemical name and use it to write a chemical formula like MgCl2. Okay? Let's start with our first example, lithium oxide.
Okay, before we even get anywhere, what elements are in this compound? What symbols, I mean? Lithium is, let's see, I can open the chat. So lithium is Li, and oxide means oxygen, which is O. So that's the first thing, is I need to know which elements, because if I can't even figure out what elements are in the compound, then I'm not going to know where to look them up on the periodic table to find their charges, okay?
So when I'm doing these kind of problems, the first thing that I want to do is find both these elements on the periodic table. I'm using this kind of weird version of the periodic table that I just wrote out. I left out a lot of the elements because they're not important for what we're doing here, and I thought they were kind of distracting. But don't be confused. This really is no different from the periodic table that you probably have in your book. It's just that it's missing a lot of the elements.
Okay, so before we kind of go through the problem, what I want to tell you guys, I would highly encourage you to somewhere like in your notes, wherever you're taking notes at, to draw something similar to this. It doesn't need to look exactly like this. You don't even need to label all the elements if you don't want to, but at least try to draw where you can label like group 1 is +1, group 2 is +2, and then kind of leave a space, skip for the transition metals, group 13 is +3, and then we kind of leave 14 blank because a lot of times the things in there, it's either tin or lead, or some of the ones up here are nonmetals and they mostly form covalent, so we don't really label that one. But then group 15 is -3, group 16 is -2, group 17 is -1. Those 6 groups, you need to know their charges, okay? So I would encourage you to kind of draw like a little sketch of this in your notes and label those 6 groups so that you know if I look, or if you have the ability to print off a periodic table from the internet and then label it with these 6 numbers at the top, okay? Because that's what's going to help you to get quick about doing the formulas and the names. Is if you have that already ready to go, you can look at it and you can say, oh, I have fluorine, that's -1, or I have potassium, that's +1. And you can just quickly look at your periodic table, find the group, and then figure out what charge it is.
Anyway, lithium, want to find that? It's right here, Li. And oxide. Oxide is just another word for oxygen. It's what we call oxygen when oxygen has a charge. I'm going to talk a little bit more about that later. And
okay, so
anyway, oxide is just another word for oxygen. And
okay, so based on, we know it's lithium, we know it's oxygen, so we know it's Li and it's O. So what charge does lithium have based on how this is labeled? All right, so Li is +1. We can see here it's in group 1, so it is labeled at the top here, +1. And then what about oxygen? Oxygen's over here in group 16. So if I look here, group 16, everything is -2. Okay, that's important. That's, again, why I need to know those charges.
Oxygen is over here. They're on opposite sides of the periodic table. Check this out, too. There's this big, thick staircase that separates lithium from oxygen. What's the staircase doing? Well, if you remember, the staircase separates the metals on this side of the periodic table from the nonmetals on this side of the periodic table. So lithium's a metal and oxygen's a nonmetal. This is important because we have a metal and a nonmetal connected together, and that means that we're dealing with an ionic compound. Ionic compounds are always metals and nonmetals. So when we have metals and nonmetals making an ionic compound, that means that the atoms in that compound have a charge. So I want to find out what the charge of those atoms is, and I can do that by looking at where they live, what column they live in on the periodic table. Here's what I mean. So lithium lives in this column, everything in this column has a +1 charge. So I'm going to write this right here, Li 1 plus. Everything in this column has a 2+ charge, 3+ charge. You might want to write this on your own periodic
He's going to
table
tell
that
you
you
to do the
have for your
same thing I
reference.
did.
Everything here has a 3- charge, and oxygen, which lives in this column, has a 2- charge. So I'm going to write it right here. So Li 1 plus, O 2-. Okay.
Okay, now here is where he's going to start doing differently from that crisscross method, okay?
So now I ask myself, does the plus charge and the minus charge balance when I have one atom of both of these?
So looking at these charges, if I have 1 lithium and 1 oxygen, are those charges balanced out and equaling 0 right now? They are not, because this is only a 1, but this one is a 2. So the method he's going to do is he's going to have you add more of them until they balance out. Okay, so let's watch it now.
The answer is no, because I have 1 plus charge, but I have 2 minus charges. So the charges don't balance. But I want to figure out how to balance them. I need to have them balanced in order to write the chemical formula. So what I can do is I can add more lithium atoms, I can add more oxygen atoms, or I can add both of them until I get the charges to balance out.
So which one do you guys think that we need to add more of to get the charges to balance out? The lithium or the oxygen? Well, not necessarily electrons, but we need another lithium atom. Yes, because we do need another electron to give away to oxygen. That's why. But yes, okay. So he's going to add another lithium now.
I have 2 minus here and only 1 plus here. So what I'm going to do is I'm going to add another lithium atom, Li plus, so that now I have 2 positive to balance out my 2 negative. And now they balance. So in order to get the charges balanced, I have to have 2 lithiums and 1 oxide or 1 oxygen. Now when I write the chemical formula, I'm literally going to say how many of each of these atoms I need in order for the charges to balance. And we've said that's 2 lithium atoms. So I'm going to write Li and then the 2 after it. That indicates that I have 2 lithium atoms. And then 1 O to show that I have 1 oxygen. And I'm not going to write anything after that. If you have a letter without anything after it, it means that you just have 1.
Okay, so the reason that I like this way better is because you see how we ended up with 2 Li's and 1 O? We don't have to reduce anything. And so it works the same way. If I have something where the charges are higher, I end up only adding the exact number I need to balance it. And so with the crisscross, you run into that problem where on some of them, you end up having to simplify and reduce the formula. And if you forget to do that, then you're going to get the answer wrong, okay? Or if you leave a 1 and forget to erase it, it's going to be wrong. But on this one, you don't have that issue. You don't have where you would need to reduce numbers, and then you just say, oh, if there's 1, I don't write the 1. So whichever way works for you. If the crisscross is easier, as long as you remember to check at the end if you need to remove a 1 or if you need to simplify the subscripts and divide them all by something to reduce them, then that's fine, okay? But this is just another method if it helps you to think about it this way as well. So we're going to look a couple more. So I'm going to let the next one pop up.
So lithium oxide, 2 lithiums and 1 oxygen is how we get the charges to balance for this compound. Here's the next one,
right,
potassium nitride.
Okay, potassium nitride. Oh, it's going to do an ad. Hold on, guys. Let's see if I can skip it. There we go. Skip the ad.
Just as before, I'm going to take out the periodic table and I'm going to find both of
Okay, so we have potassium nitride. Let me make sure.
these guys
move his
on it.
hands out of the way. Okay. Potassium nitride. So what element symbols are going to be in this formula? Somebody other than Sarema, please answer. I don't care if you type or if you unmute and say something, but please somebody else, because Sarema obviously knows what's going on, but I'm not sure about the rest of you guys because I haven't heard anything from you. So what is the symbol for potassium? Let's start simple. Is anybody there? Okay, thank you, Camila. Thank you, Gabriel. All right, potassium. Okay, so now based on where it's at on the periodic table, what charge does potassium have? Okay, thank you, Camila. +1. So we got K with a 1 plus, or K plus 1. Now, nitride, what element is that going to be? Or what symbol, I guess I should say. Let's see, who else do we have in here? We have at Ziti, we have Gift, we have Layla, we have Paige. Any of you guys want to help us out with the nitride? Okay, so oh, thank you, Camila. So yes, and Gabriel. So nitride, that means nitrogen, because remember the ending on the second one always changes to IDE. So nitride means nitrogen, which is N, capital N, and it's in this group. So I can see that it is a -3 for the charge. Okay, so that's always the first thing I need to do is I need to figure out what are the symbols for my elements and what are their charges, so that we can write them down like this. Okay. Once I have that written, then my next step is to think about, okay, as it's written right now, just having one of each of them, are the charges balanced, and does it add up to 0 or does it not add up to 0? So on this one, just having one K and one N with those charges, is it equal to 0 when I put it together or no? Okay, so Ramus says no. And that is correct because this one's a 1 and this one's a 3. Okay, so +1 and -3, that doesn't equal 0, that equals -2. All right. So that means I'm going to have to add some more of at least a 1 or sometimes both of them. So on this one, which element do we need to add more of to balance these charges? Okay, so Sarima says we're going to do potassium, we're going to do the K. How many more potassiums do you guys think that we need to add? Let's see who's out there. Yes, so we need to add 2 more of them because we need 3 altogether. Because what's going to happen is when we write it like this, I have 3 plus 1s. So if I add all 3 of those up, that gives me a +3. Okay, and that balances out the -3 on this one nitrogen. Okay, thank you, Ed City, for answering as well. So I added 2 more potassium, so I have 3 potassiums total. So now this balances because I have +3 over here, I have -3 over here. So now in the formula, what subscript will potassium have in the formula? Subscript, that's the little number that I write after the symbol, if you forgot. Oops, let's skip ahead. It should look like this. So it's 3. So I'm going to put K3. And then what about the nitrogen? What subscript will it have? N3? Are there 3 N's written up here? How many N's are written up here? Yeah, it's 1. So it's just K3N, because remember, if there is 1 of something, we don't write the 1. So again, doing it this way where we're writing out the individual atoms with their charges to show, are we balancing it? We end up not having to like reduce anything. So we're gonna keep going. Let's look at the next one. All right, so this one is sodium chloride. So sodium is over here. It's Na. Sodium is not S. S is sulfur. Okay, don't be that person that mixes them up, because there's always like a couple people every year. So sodium is Na, and it's right here. So it's going to be +1. Chloride, that's going to be chlorine, which is Cl. And it's over here in the next to last group. So it's -1. So I'm going to write their symbols and charges. So here's what we end up with. So now, do the charges balance out as written, or do we need to add more of one of them? I don't know what all those what the lines are for, but yes. So because I have a +1 and a -1, hold on, somebody's trying to get into the room. Let me let them in. Okay. So anytime your charges are the same, so this is a +1 and a -1, they're going to balance out. So I just need one of each. So this one won't have any subscripts. It would be the same if I had something that was +2 and -2. It would be the same thing, or +3 and -3, same thing. If the numbers are the same, that means I only need one of each of them. So on this one, I don't need any subscripts. So I just write NaCl, okay? If I had something that was like +2 and -2, like maybe I had calcium oxide. Calcium is +2 because it's in group 2. And oxide, that's oxygen, that's -2 because of its group. That one, it would just be CaO, okay? And I don't need 2's in the formula because the 2's are their charges, but if each of them is a 2 and I put them together, I just need one of each to balance out. All right, so let's look at this one, aluminum oxide, sorry, I almost said magnesium oxide. All right, so aluminum oxide. So aluminum, what symbol is aluminum? And based on where it's at, what charge does it have? Okay, so aluminum's Al, it's right here, it's a group 13. So if I go up here, it's a +3. And then oxide, that's good old oxygen again. You guys are you should get to the point where some elements you should have memorized, because like oxygen is in a lot of things, okay? So like you should know oxygen's -2, you should know hydrogen's +1, because hydrogen, especially after Thanksgiving break when we do acids, all acids have hydrogen in their formula and it's always +1. So there are some elements that we're gonna use a lot, so you should eventually, if you're practicing them the way you should get to the point where like you have some of them just you memorize them if you're practicing the way you should. So aluminum is +3, and then oxide is oxygen, so that's going to be our -2. All right, so on this one, do these charges balance out and equal 0 with just one atom of each? What do we think based on their charges? They do not. Okay, I have a 3 and a 2, definitely doesn't equal 0. So which one do you guys would think that we need to add more of to get it to balance? Okay, so Rama says oxygen. Anybody else have any input in here before we go over it? So you're partially right, Sarema, because what's going to happen is if I were to add another oxygen here, that would give me another -2. If I add that up, that's -4. That still doesn't balance out with 3. So then I end up adding another aluminum. So every time you have something that has one thing that has a 3 charge and the other one that has a 2, anytime you have that situation with a 3 and a 2 charge, whether it's the opposite way, it could be the 3 is the negative and the 2 is the positive. But if one charge is 3 and the other charge is 2, you want to look for like what's their least common multiple. So you have to think back to like elementary school. So what's the lowest number that 3 and 2 both multiply into? And that would be 6. Okay. And so I need to have a +6 and a -6. That's the only way I'm going to get balanced because of the numbers for the charges, because 3 and 2 are both prime numbers. 3 is odd. They don't have anything in common except for the next highest thing, which is 6. So if I want to have a +6, how many more aluminums do I need to add? So I need 3 more aluminums? But look, one aluminum is a +3. So if one aluminum is +3, I only need one more aluminum to get to +6.
I need for the charges to balance out. In this example,
so, and that's kind of what I'm going to kind of skip over here. Okay. So what he's done, he's added another aluminum. So now each one is a +3. So total, that's +6. So I think you were thinking we needed like 3 more to get to 6, but we didn't need 3 aluminums. We just needed that charge of 3. So we only need one more actual aluminum for that 3 charge. That gives me +6. So now looking at oxygen, since it's -2, how many more oxygens do we need to add to get to -6 for those charges? Yep, we need 2 more. So what's going to look like is it's going to look like this. So now +3 and +3, that adds up to give me +6. And then -2, -2, -2, that adds up to give me -6. So now those numbers, that adds up, that equals 0. So now that tells me these are the numbers that I need for my formula. So what subscript is aluminum going to have in the formula? Based on how many aluminums we have written here. So are you sure how many aluminums are written here? Yep. So it's going to be Al2, and then what subscript will the oxygen have based on how many O's we wrote? Yep, so we end up with Al2O3. Okay, because again, the subscripts don't tell me the charge. Okay, the subscripts tell me how many atoms of this element are in here. And based on their charges, based on the fact that aluminum is a +3, we need 2 of them to give me +6. And based on the fact that oxygen or oxide is -2, we need 3 of them to give us -6. And that's the only way to get the whole thing to be balanced and equal 0. Okay. Let's see. There's one more. Oh, it's going to do another add. Okay. Well, we're going to go ahead and stop that one. And then, because I want to look at a couple that have transition metals before we go to lunch, or at least one. So transition metals, it really doesn't change. The only thing that's different is that the charge is going to be in the name. Okay. For example, if I look at the one that he has written here, see how it has iron 3 oxide. Okay. The Roman numeral tells me that this iron is Fe with a +3 charge. So the only thing that's different about writing the formulas, if the name has a transition metal with these parentheses with the Roman numeral, I still have to look up oxide. Like I still have to know that that's O-2. But Fe, I don't look that up on the periodic table because the Roman numeral tells me the charge. So for example, okay, we're going to look at this one, chromium 2 iodide. So chromium is a transition metal, and I can tell because the name has a Roman numeral. Okay, that's how I can tell that it's a transition metal. And so chromium, if I look it up on the periodic table, it's this one right here. It's Cr, and it doesn't have a set charge because it's a transition metal. But the Roman numeral here in the name, that 2, this is why you got to know your Roman numerals, because I need to know that Roman numeral 2, that tells me that it's Cr with a +2 or a 2+ charge. And then for the non-metal, I looked that up just like I did the other ones on our other practice. That's iodide. So that's going to be iodine, which is the I. It's over here in group 17. So it's a -1 or a 1-. So I add one of those. And then from there, it's the same. I check, do the charges balance? If they don't balance, I see which one do I need to add more of. So in this one, they are not balanced. I would need to add another iodine. Okay. That would give me -2, which would balance out the +2 of chromium. And then my formula would be Cri2. So the process is exactly the same. The only thing that's slightly different is your charge for your metal is going to come from that Roman numeral. It's not going to come from the periodic table like our normal elements, okay, in the other practice. All right, so our bell is about to ring. So I'm going to go ahead